So thus far, most of the techniques I've shown you involve booleans. And I like booleans because they give us interesting shapes, but they're also very likely to give us bad geometry at some point or another. And so that's something that you'll need to manage in order to prevent problems when you hit the .NET. So to give you an idea of what I'm talking about, if we go up here and we first of all inspect our Boolean geometry, if we look closely here, we can probably find some sort of area where we're going into the geometry and we're not really coming out the other side. So this might be one example right here. It's kind of hard to see, but we're going through the geometry, but we're not going all the way to the other side. And so something like this is likely to create some pieces that look pretty darn weird. Now, truth be told, there's not much you can do to get around that unless you change your cutter geometry. But honestly, in this situation, it's better to not prevent the issues from occurring, but more like manage the issues so that it doesn't cause the solver to freak out. So first of all, I'm going to scale this down because what I'd like to do is get smaller pieces in general. So we'll just start off with more pieces. Right now, we don't really have enough pieces that are small enough to make it through the cracks. So while we're here, might as well just adjust that like so. But also, once we go to Boolean this stuff out, we can use the measure SOP to help us find those problem areas. So I have measure, and I set this after the assemble so that we basically go through and rename everything based on connectivity. And what I'll do with the measure SOP is I'll measure something called volume. And the way I think of this is imagine you try to turn this all into a volume, right? And you wanted to see how much room the voxels take up on that volume. Well, it's pretty much doing that. And so that's more or less what this is trying to achieve. Now, there is a bug that'll cause this to crash if I try changing something with this in the viewport. So I'm going to switch that, set it to manual so we don't crash. It'll still apparently try to update the viewport, but that's okay. Let's try it anyway. Let's say volume per piece. That piece is called name. And what you'll find when we go to the geo spreadsheet and turn this back to auto update is that we're going to get some weird values in this volume section. Some of these values are negative. And we know that, well, negative volume doesn't really exist, or at least it's not supposed to exist. These are weird values. And some of these values also reach 0 at some points. So we can identify these pieces by using a blast SOP. And we can say, if your volume and you are less than or equal to 0, go ahead and delete that. And this will also allow us to visualize what those problem pieces look like. And a lot of times they're just these weird slivers and small little pieces that essentially are practically two-dimensional in size, or they just have some sort of weird topology so that it can't really measure the volume of those pieces very effectively. Most of the time, if you end up with tiny little specks like that, that's good because you can just delete them and you visually can't tell any difference. And so that's probably the best scenario you can ask for. However, if let's say we had some big chunks showing up, and I've seen that before with a negative volume, that will allow you to target specific chunks, which are problem pieces. And with that, you can probably run a remesh node. And with the remesh, you can just target those individual pieces, and that'll usually fix your volume issue. Now, watch what happens when I do this same exact test after our second fracture. I go all the way down here. I've already set this up ahead of time. And now we have a much bigger issue at hand because all of these pieces are very noticeable. So this gives us a couple of options. We can either change the way in which we're fracturing this stuff. So maybe instead of Using a second Boolean, we can use a Voronoi fracture or a convex decomposition or something else to break things up. We could change the method. We can also try to fix this by filtering out the big pieces, doing a remesh on those, and deleting the little small slivers. That's another option. Or we can just try to delete everything and see if we can visually get away with it. In this case, I think that's going to be a bit too aggressive, just because we do have some areas that will show up in the render as shadows. But maybe if you had a terrain that was really jagged and far off in the distance, you might be able to just delete it and get away with that as well. Also, it's worth mentioning that right now, Bullet seems to be doing all right with this stuff, or at least appears to be. But in general, it's not wise to push your luck. So, that all being the case, which one should we do? In this situation, the best answer to that is to go up here to the scatter and turn down the number of planes that we're using to Boolean things out. Basically, whenever we have 3 planes being spawned, that's when we end up having these sort of issues. So instead of saying 0 to 3, I'm going to say 0 to 2, and that's going to make a huge difference in how many of these pieces we get. They're still there. I mean, we still have some problem areas like this, but this is much more manageable than it was before. And so at this point, we could just delete all of this if you'd like, or if you want to still target the bigger pieces, we can do so using a for each connected piece. That will create this connectivity node, like so. And from here, we can do a few things. One idea is using the shrink wrap SOP. That's not a bad route to go. Let's also compile this before we start refreshing this a bunch of times. So get that guy in there. Again, multi-thread when compiled. And so we could do the shrink wrap, and that sometimes works. It also sometimes makes these bulky pieces, and sometimes you have these weird things happening right here as well. So it's not a surefire way of doing that. But every now and then, that's a good way of doing it. If that's not going to work though, another way of doing this is to use another measure SOP. This time we're going for area. Area is more two-dimensional in nature, and so it's just going to measure the area of all the faces and add them up, I believe. I didn't make the area note, but I'm pretty sure that's what it's doing. Anyway, this will give us values that we can use with a split SOP. We can basically just work on our biggest pieces. And then once we have that, so let's say we have our area right here, we can find a middle value. Maybe it looks like 0.000001, something really small. And we can use that to split. So if you go to that split, let's say area, if that is greater than 0.0001, then go ahead and keep that. We can even just visually see what that's doing. Maybe just keep these guys, honestly. And then if you're over here, if you're less than that, then you get killed. So there's a blast, everything. Now to fix these guys though, we can try running a remesh. We can also try doing the whole shrink wrap thing from here. Or you can try going the volume route, VDB from polygons. If you do the volume route though, you'll need a very small voxel size for this to work. So maybe let's say 0.01 to start. Plug that in. See if that gets something. Again, it's very, very slight right here. So we probably need to even go less than that. Maybe 0.005. And then obviously from here, you can go ahead and do a VDB from polygons. And sometimes that's okay. I'm not a big fan of it though, because if we zoom in here, you could see sometimes these voxels will create these tiny islands, and that's not really that great. So you could do the volume, not really the best method though. I like doing the shrink wrap. So we do the shrink wrap, and now we've have this sort of thing going on. So there's a shrink wrap. We Then we actually don't even need this blast. We'll just only let the left input go through. Once we have that, let's use another measure, see if this worked. Measure the volume per piece. We need a connectivity stop again. Don't mind this stuff down here. Just pretend like you didn't see that. There we go. There's a measure. Here's the volume. We do still have some negative values, it looks like, but we also have some positive values. So we do have some survivors. It's great. One last time, we're going to blast anything that has a volume that's less than 0. So at volume, if that is less than or equal to 0, go ahead and get rid of that. And there we go. Here's a bunch of pieces that we were able to save. Really cool. This obviously goes back to merge with the main stream, and that is how you go about fixing these pieces. Honestly, this is something you should almost always do, just because you want to keep things as clean as possible when you're doing multiple fractures. That is the moral of the story.